Hello and welcome back to HW2.5. Almost done. Test next week. No, yeah, next week. Okay, but real quick, let's scroll up here and look at this. CPCTC. Remember that is corresponding. In other words, if you can prove the whole triangle is matchy-matchy, then any corresponding part must match as well. Which can gain you knowledge that you didn't know necessarily before you proved that the triangles have to be congruent. So it's like an extender. You prove something and then you get this through CPCTC, you get all the parts, all 6 parts. Because usually it takes 3 parts to prove 2 triangles, 3 pairs of features. SAS, SSS, something like that. 3 pairs of features to prove 2 triangles are congruent. And then you get the other 3 after that for free through CPCTC. Okay, now down here, the retrieval. One is the preimage, the other one's the image. You can do this. Transformation x plus 0. I guess this is the retrieval. We're supposed to do it together. It's a funny y. Plus, how much do you want to bet it's going to say? Write the equation. Oh, we'll write the equation, all right. Yep, write the equation of each line. I'm actually going to focus on this because we could just do the slope, which is down 1 over, down 2 over, down 3 over 4, negative 3/4, and do the intercept. But I want to show you this other thing you can do, which is to say, I'm going to use the slope all right, but now I'm only going to use it as I move away from this point where x is 4. Right? This is the point 4 comma negative 6. So I'm going to write x minus 4. Now if I put in 4, 4 minus 4 is 0. 0 times negative 4 3/4 is 0. So if I put this into my equation so far, I'm getting 0. But I don't want 0, I want negative 6. So I'll just tack that on here. And this is also an equation for the line. It's called point slope because it has this point. The opposite of this number, comma this number. This is literally this point is 4 comma negative 6, and look, 4 comma negative 6 is in my equation. And if I wanted to distribute, what's negative 3 for positive 3? What am I screwing up here? Which was not part of that distribution. Combine like terms, and it's negative 3/4 x minus 3 with the y-intercept at ding ding negative 3. So this equation describes the line. This equation describes the line. This one's faster to write if there is no nice y-intercept. Let's practice that again here. Now this line is, if you put in 4, it spits out negative 1. Slope's the same, so negative 3/4 x minus 4. But that, if I put 4 in, it'll zero it all out, but I don't want it 0, I want it negative 1, so I'll put that on there. Drafting, architecture, and geometry. Drafting is the art of drawing schematics to build stuff, like engineering, laying out the exact measurements to build stuff. That's draft. So it's like architecture, but not for buildings. You can draft a schematic for this document camera. You could draft a schematic for a computer. You could draft a schematic for a table or a chair. Architecture is a type of drafting for buildings, and in geometry in general. Geometric compass. So the thing that makes circles. Why do we use it? All radii of congruent circles. It preserves distance. it's a distance that you can carry around and guarantee. You can guarantee if you make a circle, you can guarantee in every direction is the same distance. The radius. That's called the radius. All right, so let's get in here. These ones are easy because their y-intercepts are blah. Ooh, here's one. When you want the equation for the image, slope is -3. So you pick, you want to, this point is at 4 again, 4 comma 2. What, so why am I picking on this? Because there is no, I mean, it's up there somewhere, but I don't know what the y-intercept is. So I'm going to zero it out. By zero it out, I mean if we got to put these numbers in for x, right? Put a number in for x, you get something out for y. Put a number in for x, you get something out for y. Put this special number in for x, and I want this point to come out. This special number is 4, so I subtract 4, so that when I put in 4, it zeroes it out. And then, there. So fast, so easy. Especially like here, you don't have to figure out what the y-intercept would be. Referring back to the graph from problem 3, write an equation for a line with the same slope that goes through the origin. What's the slope? 2, 3. If it goes through the origin, the y-intercept is 0. It's that easy. Oh my, oh prime. Sheesh. Perpendicular to both lines. Now we want to, when we put in 2, or -2, so that's 0. This is the point slope version, see? Create the explicit equation for each of the tables and values. So this, okay, we're at 14 here. We're going to pin to 14. But we go one direction, we go up 2. If we go backwards. If we go forwards, we go down 2. So we want something that when we put in a different x, we'll move it 2. There it is. Take the x, multiply by -2. If x is small, like 1, then you just go down 2. If x is 2, then you'll go down 4 total from the original 14. That's why we pin it. That's the y-intercept. So they give you the y-intercept in all of these. So these aren't going to be very difficult. You just got to figure out the slope. Except they're all parallel. What are they doing? Well, they're making your homework easy. Ooh. Alright, so these, the diagram shows 2 overlapping triangles, triangle BAC, triangle ABD. Draw each triangle separately. BAC. Draw that triangle. Okay. Connect it, make a triangle, and then label the congruent parts. Because you're going to draw 2 triangles and then compare their parts. Do a better job than this. I'm just sketching out some ideas so that you can figure out. Basically, you're pulling this apart into 2 separate triangles. Because the other one's ABD. ABD. So pull that triangle away. You'll have 2. A and B will be in both triangles. Maybe that's a clue for one of the markings. And there should be some markings. Oh yeah, especially because, wait, actually, what can you prove here? Marked. These 2 angles are marked. So find those angles in their triangles. Man, it's floppy. And then add a line to the given diagram to create triangles that can be used for reasoning about the figure. Yeah, what would help you make some conclusions? Hint, it was in the lesson. It was the last part of the lesson where I said work on this. For each of the following problems, there are some true statements listed. For these statements, a conjecture, some conclusion about what might be true has been made. Use the true statements and the diagrams to create an argument to justify the conjecture. Okay, so we're getting into proofs. This is how this works. Things we know. Point M is the midpoint of DB. Alright, well if that's the midpoint, then this and this are congruent. Go ahead and mark that. Angle ABD is congruent to BDC. ABD congruent to BDC. BDC. Shaded in a little bit. Fancy. And segment AB is congruent to segment DC. AB, DC. And they want us to prove what? That angle A and angle C are the same? Well, I guess we don't really care about the midpoint. That was a distraction because the fact of the matter is this side is in both triangles. And that's called the reflexive property, something is equal to itself. So, we can just say that dB. I actually like to reverse it and say BD, but you don't actually see that. People just repeat it usually. dB congruent to dB. That's because the reflexive property. Something equals itself, okay? It's not a hard property. So that's a pair of sides. We have a pair of angles. I'm repeating this fact up here. This, to some people, myself included, this is the least fun part of geometry, rewriting things that are already stated. But I'm using it to build an argument, because here's a pair of sides, here's a pair of angles, and do I have one more pair of sides? Yes, I do. They already told us, rewriting it, the worst, segment AB, segment DC. There's a side we have SAS congruence. Now you might be saying, why do I want to prove the triangles are congruent? I thought we were trying to prove these angles are congruent. Yeah, but those angles are corresponding angles of these two triangles. So if I can prove the triangles are congruent, then I can use CPCTC. Which I can, because triangle, let's just call it ABD, is congruent to triangle. If I started here, okay, I traveled this way, no, I traveled this way, along the double CDB. Make sure the orientation matches. Because SAS, therefore, now this is not the worst, even though I'm rewriting this, I'm about to prove it, so that's more fun to write. Angle A is congruent to angle C, because C, P, C, T, C. So that saves us from having to write. Corresponding parts of congruent triangles are congruent. Proved. Now your chance to prove something. You're trying to prove that JK bisects MKL, angle MKL. How could you prove it bisects? Remember, a angle bisector splits an angle into two equal parts. So what you're really trying to prove is that these two angles are the same. Do you know enough about these two triangles, like the fact that these other angles, KJL and KJM, are congruent? And you know something about some segments. How about shared side? Like both triangles share a side in the middle, so you can use the reflexive property to say JK is equal to itself. can you get to a point where you can say these angles must be the same, therefore JK is a bisector? Try to work it out. Build it one step at a time, just like the last problem. Build it out. Have a goal. This last one is a little trickier. It uses rotation, but if we look at this, it says ADM is a 180 rotation of CMB. So I actually should be doing CMB. Well, whatever. It's a 180. If it's a rotation, it'll work both ways. So A ended up down here. What am I doing? I'm making little notes that this angle is made up of an AM section, which goes down here, and this is this, and these are congruent too because they rotated. But we're trying. It would be done SSS if we were trying to do these. Are we? No, we're trying to do ABM. Triangle ABM. We don't have the third side. Now here's the thing. This segment, what a 180-degree rotation means, these are in a line, and these are in a line. So when two straight lines cross, wherever two straight lines cross, the angles across from each other are congruent. So you can use that fact. Because they cross at a vertex, this is called vertexical angles. Just kidding. They don't put. It's just called vertex angles. Oops. They don't use the old-timey vertex. They use a new vertical. Yeah, they're called vertical angles, weirdly. But it comes from vertex. Because they meet at a point. See, these are meeting here. So these angles are across from each other where two straight lines meet. They have to be straight lines, obviously. So you can use the fact that those two angles are congruent. So now you basically have all the pieces. Just document it. Rewrite stuff, document. If you want a reason why you can say that DM is the same as BM, you can say definition of rotation. And the rest of it, we literally answered this in the retrieval. And all of these constructions are review. We're getting almost to our test. Look, we're almost done. All right. Have fun with that homework. Oh, should have put the secret word somewhere in the middle. Secret word is compass. Come and claim if you haven't claimed one yet. And it hasn't been claimed yet this period. All right, bye.